Hello, now I will explain you about how to calculate linear programming case with QM software. The case is from Real Case. I use Bolu.Akinibuotang as the company. And here is the case study. The first step to solve this problem is we must to determine the decision variable. For this case the first step to solve this problem is we must to determine the decision variable. For this case let us determine x1 as Q-Kering, x2 as Bolu Loyang, and x3 as Bolugilang. Then determine the objective function. In this case we use max z because we want to maximize the profit. The objective function is based on the profit for each product. 20,000 x1 plus 12,000 x2 plus 8,000 x3 plus 1. The third is determine the constraint. 300 x1 plus 200 x2 plus 100 x3 less than 20,000 and so on. To solve, here is the table from QM software. In QM software we use simplex method to solve linear programming case. And here is the first iteration table. The second iteration table, Q-Kering as the entering variable and /7 as the leaving variable. In maximization case we do the iteration again if in CJZJ still consist of positive value. Entering variable and /4 as leaving variable. Third iteration table, Bolu Loyang as entering variable and /4 as leaving variable. There is still positive value so we must do the iteration again. Bolugilang as entering variable and /10 as leaving variable. Fourth iteration table, Bolugilang as entering variable and /10 as leaving variable. There is no positive value, so the iteration end in here. Who has zero value in /surplus is in ranging table. Based on that table we can see that who has zero value in /surplus is cheese and essence. To calculate the sensitivity analysis we need that variable. Zero value mean that source is rare. That must produce to make optimum solution is, as we can see from the table, the amount of Q-Kering that must produce to make optimum solution is 5.7, and that is strange because the number of product must be in integer. The linear programming calculation is used to calculate the sensitivity analysis based on the /surplus variable. Become integer value. Here is integer programming make the value of optimum solution become integer value. Here is the original table form. Programming using branch and bound method. In this case, iteration result in integer programming using branch and bound method. In this case, we do the iteration just until level 1. See, we must produce 5 topless Q in integer programming result. We can see, we must produce 5 topless Q-Kering and 15 Bolu Loyang and then Bolugilang, with the optimum profit is 340,000 rupees. Especially cheese. Why I choose cheese? Sensitivity analysis change the source of the material, especially cheese. Why I choose cheese? Because based on the linear programming I can see that cheese is slack surplus, that mean cheese is rare material. To calculate the sensitivity analysis I use cheese constraint and change the maximal supply, and finally I got the table below. How to read the table is, if we change the maximal supply to 600 gram, the optimum solution will be 7 Q Kering, 15 Bolu Loyang and 10 Bolu Gilang, and the maximum profit will increase until 38,000. Conclusion: the number of optimum solution of this case are produce 5 tuples Q Kering, 15. Conclusion: the number of optimum solution of this case are produce 5 tuples Q Kering, 15 Loyang Bolu, Dan 10 pieces Bolu Gilang. The estimation of profit: if they apply this suggestion they will get 340,000 profit each day. If they increase the stock of cheese until 1.6 kilograms they can increase profit until 64,000. 100 x 3 less than 20,000.